We're going to take a look at number 47 from section 1.5, which deals with complex numbers. So for number 47, it looks like we are provided this division problem of 2i divided by 7 plus I. Okay. The main idea behind problems like these are that we want to rationalize the denominator. In other words, when you rationalize the denominator, you want to make sure that you have an integer value in the denominator. So I never want to see any sort of imaginary number, and I don't want to see any sort of square root living there. And right now, as you can see, and I'll highlight it in green, I have an I in there. So I need to somehow figure out how to get it out. So what we will go ahead and do is we're going to multiply both the top of this expression and the bottom of this expression by the conjugate of 7 plus I. And if you notice by comparing what I have in blue to what I have in orange, the conjugate really means that I have the same structure of this, we'll call it a binomials because we have 7 plus I. Basically it has the same structure, but the sign in between the two terms, they're different. So one other thing that I'm going to do is I'm going to go ahead and take all of my binomials and I'm going to put them into parentheses. And why might I want to do that? If you said because it's going to help remind you to distribute appropriately in order to solve the problem, then you're spot on. So what you can do here as well is you can break this up into two problems. You can take care of the multiplication up in the numerator and then take care of the multiplication in the denominator. So we'll go ahead and do that. So 2i times 7 will give you 14i, and then 2i times negative I will give you negative 2i squared. And then we'll move to the denominator here. So we will have 7 times 7, which will give you 49. 7 times negative I, so negative 7i. Positive I times 7, so positive 7i. And then positive I times negative I, which will give you negative I squared. Okay. So really what I can do here is I can do a little bit more manipulation. So we have our 14i, and then we have minus 2, and our I squareds will actually be negative 1s. Okay, because since we know that I, and I'll write it over here on the left, I is equal to the square root of negative 1. If we have I squared, that means that we're going to take that square root of negative 1 and square it. The square and the square root are inverses of each other, so that's why we're left with this negative 1. Okay, so we'll clean up our denominator. So we have 49. Notice that the two middle terms that you have here are additive inverses of each other, so they're just going to cancel each other out. And then we have a minus, and then we have that I squared turns into a negative 1. So now we will have, I'm going to go ahead and switch this around a little bit in the numerator. So our negative 2 times negative 1 will give us a positive 2, and that's going to be plus 14i. I know that it's plus because this 14i is positive. Okay, if it was negative, it would have the negative sign out in front of it. And then on the bottom here, we have 49 minus a negative 1. These negatives make it positive, so this becomes 50. And then finally, we can go ahead and break it out of its shorthand. We know that each term in the numerator shares that same common denominator. So we have 2 over 50 plus 14 over 50, and then the I. And we can go ahead and simplify this down. This becomes 1 over 25 if you reduce the top and the bottom by 2. And then if you reduce the top and the bottom of 14 over 50, that becomes 7 over 25i. Note here that I presented my answer in that standard form of a plus bi. Okay, so what you have here circled in red is your final solution.